Hello and welcome to another exciting video from Vlab Solutions. Imagine a world where machines can understand our language, interpret complex images, and even generate creative content. This future, once confined to the realm of science fiction, is rapidly becoming a reality thanks to groundbreaking advancements in artificial intelligence, particularly in the field of foundation models. These powerful AI systems are poised to revolutionize industries, redefine the boundaries of human creativity, and reshape our interaction with technology. Artificial intelligence, at its core, aims to replicate the cognitive abilities of the human mind in machines. This includes tasks such as learning, problem-solving, decision-making, and even understanding and responding to natural language. Traditional AI systems were often designed for specific tasks, limited by the scope of their programming and training data. However, foundation models represent a significant leap forward, promising a more generalized and adaptable form of artificial intelligence. Foundation models are a new class of AI models trained on massive datasets of text and code, encompassing a variety of sources such as books, articles, websites, and even software repositories. These models are designed to understand and generate human-like text, making them incredibly versatile. This extensive training enables them to perform a wide range of tasks, from answering questions and summarizing documents to translating languages and even writing code. The potential applications are vast and continually expanding as the technology evolves. Unlike their predecessors, which required explicit programming for each function, these models learn fundamental patterns and relationships within data, allowing them to generalize from their training and apply their knowledge to new, unseen scenarios. This ability to learn and adapt is what makes foundation models so powerful. This adaptability means they can generate novel outputs, such as creating realistic images from textual descriptions or composing music. They can also adapt to new environments and tasks with minimal additional training, making them highly efficient and effective. They serve as a foundation for building more specialized AI systems, hence the name foundation models. These specialized systems can be fine-tuned for specific tasks, leveraging the broad knowledge base of the foundation model to achieve high performance in niche areas. This adaptability and generalization are key characteristics that set them apart from traditional AI. Traditional AI systems often struggle with tasks outside their narrow training, but foundation models excel in diverse and dynamic environments, continually learning and evolving over time. Traditional AI models often resembled isolated islands, each trained for a specific purpose. Imagine a calculator designed solely for addition, or a chess program limited to playing that specific game. In contrast, foundation models are more akin to a vast continent, with diverse landscapes representing various capabilities. These models can seamlessly transition from translating languages to writing different kinds of creative text formats, like poems, code, scripts, musical pieces, email letters, and so on, all while drawing upon their vast knowledge base. Learning from the world's self-supervised learning and foundation model architecture. In this section, we delve into the fascinating world of self-supervised learning and the architecture of foundation models, which are revolutionizing the field of artificial intelligence. The power of foundation models stems from their unique training process known as self-supervised learning. This method allows models to learn from vast amounts of unlabeled data, making them incredibly versatile and powerful. Instead of relying on explicitly labeled data, these models learn by identifying patterns and relationships within the data itself. This approach mimics the way humans learn from their environment, making the models more adaptable and efficient. Imagine a child learning to speak by listening to conversations and observing how words are used in different contexts. The child doesn't need a dictionary to understand language. They learn through exposure and interaction. Similarly, foundation models are fed massive amounts of text and code, learning the intricacies of language and structure without explicit human intervention. This process enables them to understand and generate human-like text, solve complex problems, and even write code. The architecture of these models is designed to handle diverse tasks, from natural language processing to computer vision. By leveraging self-supervised learning, they can adapt to new challenges with minimal additional training. This adaptability is what makes foundation models so groundbreaking. They are not limited to specific tasks, but can be fine-tuned for a wide range of applications, making them invaluable tools in the advancement of AI technology. As we continue to explore and develop these models, the potential for innovation in AI grows exponentially. The future of AI is bright, with self-supervised learning and foundation models leading the way. Building blocks of knowledge. Understanding foundation models through analogies. To grasp the architecture of a foundation model, envision a vast library. Each book represents a piece of data, and the model acts as a tireless reader, absorbing information and organizing it into interconnected categories. This interconnected web of knowledge allows the model to understand context, identify patterns, and generate creative outputs. The more data it reads, the more comprehensive its understanding becomes, enabling it to tackle increasingly complex tasks. A world transformed real-world applications of foundation models. These models are revolutionizing the way we interact with technology and each other. The impact of foundation models is already being felt across various sectors. From healthcare to finance and from education to entertainment, these models are making a significant difference. In natural language processing, they power advanced chatbots, facilitate seamless language translation, and provide real-time customer support, making communication more efficient and effective. They enable the creation of realistic dialogue for virtual assistants, making our interactions with technology more natural and intuitive. Imagine asking your virtual assistant to book a flight, and it understands and responds just like a human travel agent. In computer vision, they enhance image recognition, automate object detection, and improve the accuracy of visual data analysis. This is particularly useful in fields like healthcare, where precise image analysis can save lives. They even assist in medical diagnoses by analyzing complex medical data and providing insights that help doctors make better decisions. This leads to more accurate diagnoses and personalized treatment plans. Their ability to analyze vast data sets makes them invaluable in fields like finance. They can detect fraud by identifying unusual patterns, predict market trends with high accuracy, and personalize financial advice based on individual needs. Imagine having a financial advisor that knows your spending habits, investment preferences, and financial goals, and can provide tailored advice to help you achieve them. Foundation models are making this a reality, transforming the way we manage our finances. Navigating the challenges, bias, explainability, and ethical considerations. Despite their immense potential, foundation models are not without challenges. The massive data sets used for training can inadvertently perpetuate societal biases present in the data itself, leading to unfair or discriminatory outcomes. Additionally, the complex inner workings of these models make it difficult to understand their decision-making processes, raising concerns about transparency and accountability. Addressing these ethical considerations is crucial to ensure the responsible development and deployment of foundation models. The future of intelligence, foundation models, and the unknown. As foundation models continue to evolve, their potential applications seem limitless. Will they unlock new frontiers in scientific discovery, accelerate artistic expression, or even redefine the very nature of intelligence itself? The answers to these questions remain shrouded in the unknown, but one thing is certain: the journey into the era of foundation models promises to be both exhilarating and transformative. The power of foundation models. A recap. Foundation models represent a paradigm shift in artificial intelligence, moving away from task-specific systems to more generalized and adaptable models. Their ability to learn from vast datasets through self-supervised learning empowers them to perform a wide array of tasks, revolutionizing fields like natural language processing and computer vision. However, it is crucial to address ethical concerns surrounding bias and explainability to ensure their responsible development and deployment. Unlocking a new era of possibilities. The advent of foundation models marks a pivotal moment in the evolution of artificial intelligence. As we delve deeper into the capabilities of these powerful systems, we unlock a world of possibilities previously unimaginable. By fostering collaboration, promoting ethical considerations, and embracing the transformative potential of foundation models, we can shape a future where artificial intelligence augments human ingenuity and drives progress for the benefit of all. Thanks for watching and subscribe to VLab Solutions.